Swayam Prabha. Digital India. Educated India.
Hello everyone. So welcome to the laboratory exercise 8. So today we'll be continuing with the functional decomposition, but this time we'll do another method of functional decomposition. So you are familiar with the different methods of functional decomposition. The first one we discussed was the first method, and then today we'll look at the flow method of functional decomposition, or sometimes we call it as the function structure method also. And we take a simple product, which is the handheld blender. The blender is something which is commonly used in households, basically to blend some liquid or some semi-solids. So this product has got some features where actually the human will be holding it and then it will be used to mix ingredients. So as a product, it requires a lot of supporting things to work. So it cannot work on its own just by switching on. Somebody has to hold, so we need to have some container and things like that to support the use of the product. So we'll look at this product today and then see how the flow method of functional decomposition can be used for getting the various functions of this particular product. Then again, it's a very simple product which every one of you will be able to easily understand. So let us look at the main objectives of this exercise. Like any other exercise, the primary purpose is for you to go through the product and understand the different parts of the product and how these parts actually contribute to the main function of the product. So you'll be going through the product and then understand the functioning of the product, and then identify all the parts and sub-assemblies, prepare the parts list and assembly chart, and then you will be preparing a functional decomposition using the flow method. So in every lab exercise, there are two fundamental purpose or fundamental objectives. The first objective is for you to introduce to this product to you, so that you will understand how a particular product works, and that will help you to develop some kind of understanding on various parts of the product and how these parts are actually contributing to a particular function. And this will help you to have a good repository of parts and concepts, to develop new products. So any person who wants to develop new product should have some kind of an understanding of how different parts work and what way they contribute and what are the challenges in using those parts. So that is what the one objective of doing any lab exercise or any of these exercises. That part is there. So you will be doing that part first, and then we look at the concepts and the theory that we learn in the classes, in the theory class. We want to apply that to this particular product and then get some kind of a familiarization of that particular methodology. So flow method is one of the very commonly used function decomposition method, and so we will use that method to identify the functions of this product in the functional decomposition. So let us look at this product. So the product is the handheld blender. So this part will go into the for blending, and this has got the other electrical and electronic parts, and someone will be holding it and then you can actually use it. So you'll be actually supplying hand force to that, and then there will be some other things which you need to understand when the product is being used. Again, this is Usha make, and the model is Lexus. There are so many variations of this available, used domestically or in restaurants and hotels to mix solids or semi-solids or liquids. Okay, so the primary function is to mix or blend liquid or solid, which will be kept in a container, and then you try to use this blender to blend them well for some purpose. So that is the primary requirement of primary function of this product. And in order to do that, we need to have many sub-functions, basically to rotate the blades, then provide speed control, absorb the vibrations, and blend or the puree food item. So these are the things which need to be accomplished in the product in order to achieve the main function of mixing or blending of liquid and solid. And then what we'll do, or how will we do this? We will actually do the procedure almost the same in all the previous cases also, where we try to understand the functions, features of the product. Fasteners will be removed, identify the parts and their functions, then prepare the parts list and product structure, identify the flow. So this is what actually will be different from the previous experiments or previous lab exercises. So here you need to identify the main flow. So now, by now you must be knowing what we mean by a flow. So you can actually have an energy flow, or you can have a material flow, or you can have an information or a signal flow. That is the input to the system, and then there will be an output of these flows also. So if you take any product, then you will be able to identify the flows. So this is the way how we define it. So in this product, try to identify what are the flows that is taking place in terms of energy. So you can have an energy, material, or signal, or information, whatever it is. So any one of these, or you can actually identify multiple energy signals, or multiple materials, or multiple signals. And then you will see that this is input, this is the output. So output also will be in the same format. So you will be having energy. So some energy will be coming out, and some material will be coming out, and then some signal will be coming out. So you need to see what are these energy, material, and signal flows in the product. Once you identified this, then you will know, okay, how this energy is getting converted to something else. So now this energy may be going through different processes and finally coming out as some other energy. So each one will be having some function, and finally after this it will be going out. And sometimes there may be some branching of this energy also for some other purpose. Similarly, the material also will come in, and then the material will be having some function happening to it, and finally the material will be going out. Similarly, the signal also. So you need to identify what are these functions which actually convert the input signal to an output signal, or what are the things it should what are the things it happen inside in order to get this conversion. So the material, maybe you are giving two liquids, or one liquid and semi-liquid, and finally you are getting it as a mix. So how is this happening? So what is that actually need to be done inside? So that is what basically the functions of the product. So using this energy, material, and the signal input, you need to find out how these are actually getting converted to different flows, and all these will become the functions within the product, and that becomes the functional decomposition. So this is what you need to do in this exercise. First identify the flows, and then do the decomposition using the flow method. So we have done few exercises in the class. I mean, the theory class, we have shown you some examples also how the decomposition can be done using flow method. So please follow the same, and then try to get the decomposition, and then prepare the reports, and then submit the reports. Okay, so the report format is given. It's almost the same as the previous reports, except that finally you will be having a flow method of functional decomposition. So what I will be looking for in this exercise is, since these are common to all, which you will be able to easily do, I will be looking for, okay, how much you have understood the functional decomposition using flow method, and how you are able to do this for a new product, a product which is not familiar to you, or which you have not been exposed to. How can you develop the functional decomposition? So I told you about the importance of the functional decomposition in the design of products, because each function we need to identify a part or a sub-assembly which will be able to provide that function. So understanding the function is important in designing new product, because once you understand what the function it has to provide, then we can actually identify a particular part or a sub-assembly or a new concept for satisfying that function. So that is what actually we'll be doing in the new product design. So please go through the following video of the decomposition of the product. So the teaching assistant will be explaining to you in detail about the decomposition, the product dissection, and then various parts in the product, and how each part is contributing to the product's function. So based on that, prepare the report and then submit the report. Thank you.
Hi all. So today we will be looking at two products, two simple and interesting products. So one will be the handheld blender, which we will use in kitchen for daily purposes. And the other one will be the breath analyzer, handheld breath analyzer, which we use to detect alcohol content in breath. So let us first start off with the first product, which is our handheld blender. So this should be quite familiar, right? So we use it in kitchens. So another version of this would be used for industries where they want to mix up paints or emulsifiers, things like that. So let us now look at the parts of the handheld blender that we are having as of now. This brand is from Usha, from the line Lexus. And let us now look at the markings of it, the model number, and how much of wattage and volt. So whenever we look at a product, we should first look at its ratings. So according to it, we have to use it, like whether it is for 230 volts or 220 volts. If in case it is 220 volts, then we have to use some adapter for operating it. So when we look at this product, we can see that it is easy to handle, and the design is in such a way that you can hold, that is the customer can hold it, not feel the entire weight of the machine, and at the same time control the button, that is a speed control button, without knowing the weight of the motor which is housed inside this. So now we are going to open this. We are able to see that this is the power cord. So this will be the power cord. And if you see here, there's a screw. So actually this is not in working condition, but if you see in most of the handheld blenders, you won't be able to see the screws. For aesthetic purposes, there will be a silicone closing to it so that none of the screws are visible. So let us now unscrew this. Okay, so actually the whole handheld blender consists of two parts. One is the lower part and the upper body part. So body part is the housing which contains the motor, and the lower is going to provide the rotor blade, that is the mixing action. So we can easily just twist it and remove it. So if you can see, this is the lower portion. You will be able to see where the motor shaft attaches it, and in this portion you will be able to see the blades. So this is the portion which comes in contact with the food or any product that you are going to be mixing. The blades here that you see, they are going to be manufactured by method of stamping and forging processes. And the housing that you can see, this is polypropylene or polystyrene, which is done by injection molding. So let us now look at the upper body part, which is going to provide the workforce. Okay. So let us now safeguard the screws. We place it separately. So here we are able to see the opened up part. We are able to see the motor which produces the workforce here, and the circuitry which is going to supply. Let us now just move this away. So here you will be able to clearly see where exactly the power is being supplied, and you can see a clear PCB board which is housed. So we can actually open up the PCB board also. Okay. So now we have the PCB board in our hand, you can see. So the entire circuitry of getting the power supply and providing it to the motor has been simply embossed in this small PCB board. You can see behind that there are several portions which are the wire units. You can see that these two will be connected to the power supply. The same which is going to be given to the motor will come. Okay, it is not connected, but understand that these two ports will be connected, would actually be soldered here. Okay. And the capacitor that you see here is used for adaptive noise control and to also regulate the voltage. Here you are able to see two switches, right? This is a spring mechanism. They have placed two springs here and they are going to control the speed of the motor. Okay, the speed of the motor here, it is controlled by a thyristor circuit. So let me now show you the motor. So if you see, it has a rubber surge. This is a surge protector. What this is going to do is, if you see the other portion, this also has a rubber sheeting. This rubber sheeting is provided in order to absorb the vibration generated by the motor, and this vibration of the motor should not be felt by the user, who is going to hold the blender here. So if you see, this is a cavity wherein nothing will be placed, only your PCB will be there, a cavity is there, and a surge protector where the vibrations of the motor will be absorbed. Here you will be able to see that the surge protector, the other surge protector being placed towards the base of the motor. So now let us look at this motor that we have at hand. This is a universal motor. Universal motor which works on both AC and DC. Here we have this AC series motor which is going to have two holdings, which is on top and below. Here towards the end you can find the shaft. This shaft is going to be attached to the rotor blade. Sorry, this is the blade which is going to provide our mixing motion. The shaft, this shaft, motor shaft will be attached to the shaft of the blade. So whatever motion is being provided at this shaft is transferred to the lower portion. The aim behind this is that you can easily clean the lower portion. Lower portion is what is going to come in contact with the food. You are going to clean it so that there is less contamination with contamination of water. And the electrical products are safeguarded. So here you see that there is a magnetic casing. This is a stator coil. Stator coil you can see here. Is it visible? This is the magnet and you have the stator coil. Inside you will be able to see the rotor housing. Here we are not dissecting the entire motor. I will just show you the parts just for the time's sake. So you can go ahead and research more on this universal motor. This is actually used in vacuum cleaners and other household products that we are using. Basically the disadvantage we see is that it causes a lot of noise. So if you see here, these are the brushes. The two sides we have the brushes and the center portion is the commutator. Okay, the brushes over the period of usage will start to wear. The brushes that we see here are something of a mechanical linkage for power supply. They connect to the commutator and the required force, mechanical force is provided. If you see the motion, how it is moving, the entire, based on the reversal of the polarity in the stator, our rotor coil is moving. And the shaft produces this mechanical motion which is transferred to the shaft, that is the shaft of the blade, which we have as the lower portion. Fine. The speed control, as we said, is controlled using a thyristor circuit, which is a bistable switch. I urge you to please read about the thyristor circuit. So let us just see the different parts that we have dissected. Here we again see that there is a button which we can actually, this is a rubber portion. If you are able to see, we can press it under this lies this PCB board ka switch. So the spring mechanism provides the given speed control. Let us now start assembling the product. Before that, I will show you the disassembled product. So initially we have the power supply, the lower portion, and this is the complete upper portion which is going to provide the workforce. The lower portion consists of a housing, plastic housing, which contains our shaft, blade shaft. The blade again is, you can see a nice, a sharp and a bending structure if you are able to see, and there are holes provided so that the required food, that is, it will start rotating, create a tornado kind of a movement, and the blended food product will come out via the openings. You can also look upon the usual blenders that we use in kitchens. It is really interesting to compare these two and find the working of both. So again, this will be the top portion, and you can see the rubber surge protector. This will be produced by injection molding or vulcanization. This is the other part, and the PCB as such is a very interesting topic. I would like you to see how a PCB board is being prepared. So it starts off with your circuit, it goes into the schematic portion of it, and the schematic again is given to a CAM engineer who is going to do it like according to the rules. According to the rules, he is going to provide a schematic in some software called Eagle, and then the PCB board that we are seeing here is either a fiber reinforced, glass fiber reinforced material, upon which these copper, there will be copper wirings which follow the schematic that we want. All these points which come from top to bottom are the via points. And finally, they will, it is laminated and again etched, oxidized to prevent further damage and electrical interferences. So please do look at the PCB fabrication. And finally, we saw about the universal motor, wherein we saw its parts. I have not dissected the entire motor owing to the time restriction. So we will, but please look at the individual parts of a universal motor. This can be used for both AC and DC. It is actually a commutator series DC motor, sorry, AC motor. So we are going to put everything back. You can find the easy snap fit motion, and here again we have two screws. The major portion of such handheld blenders or any handheld product is the fact that it comes with easy replacing components and easy fitting also. If you see, this is just a snap fit and we have the entire product assembled. This is quite an old version or quite an old model of the immersion blender. This also called as a stick blender, has many names. So we have the final product assembled. So if you see, the basic design advantages are that it is easy to fit and snap back, and the button, the holding position, you will not be able to feel the weight of the motor because the motor is housed below, and the holding portion, the entire holding grip, the design has been provided in such a way that the holding is possible, at the same time you are able to press the button. These are the design advantages. Disadvantage would be as of such the noise of the motor, but for a universal motor apparently we are not able to find any other solutions for the sound of the motor that is being produced, but other than that, this is a good design. Moving on to our next product, which is a breathalyzer or breath analyzer. So usually police officers come across accidents. You should see the statistics of accidents which are caused due to driving under influence or driving while intoxicated, which is alcohol consumption. So you see most of the accidents are being proved whether they are not under intoxication or not. So for that purpose, we have this handheld breath analyzing device or the breathalyzer. The other more advanced version would be to check the urine or blood of the person. But in a case wherein you are standing on the road and you want to test the person, this is the best approach. But you have to understand one fact, that this breath that we are analyzing is it is going to have a different proportion of alcohol to that of blood. So breath and blood, BAC we call it, breath alcohol content. So it is going to be 2100:1 ratio. That is, for 1 millimeter of blood, it contains 2100 parts of alcohol when compared to 1 part in 1 mm of 1 millimeter of air. So let us now look at the product as such. So you will be able to see there are actually 3 methods by which this breath analysis can be done. One being semiconductor based, fuel cell tester based, and the other one being IR, that is infrared testing. Here they are going to use a very simple sensor which is going to be, I'll show you the sensor. So you can see this is a sensor. It's a very small mesh network kind of a sensor, and you will be provided with several tubes via which you are going to breathe. So not the one tube will be placed here, and via this tube you will be blowing the air into it. So if you see the design of the tube itself, there will be holes on the sides. So the airflow is going to come from top. The direct, that is the flow which is going to be direct, will fall on the sensor which is going to be placed towards the end, and the remaining will be moved out. So even the blowing portion of the breath analyzer has a specific design as to provide compliant flow, so that the flow of breath is directed towards the intended sensor. Okay. So actually I have opened the sensor previously. You can see that this is the basic sensor, and your sensor will be placed here. So you're going to breathe in via this portion, and the alcohol breath is going to fall on the sensor. It is being detected via the sensor based on resistance changes. I will explain it. And these are going to be the ground VCC connection and the signal connection to our IC. So you can actually remove it completely. So this is the IC board or the PCB board. Sorry. So the PCB board consists here of the LCD display. So whatever input is being brought in is going to be processed by the microcontroller, and it is going to be displayed in the LCD. It has provisions for memory and reset button also. So these two are memory and reset buttons. And you have a buzzer which provides whether it is going to be higher than the limiting number. So here in India it is going to be 0.03%. It is considered that the person is under the influence of alcohol at 0.05, and you cannot make critical or analytical decisions at 0.05, but the limit here in India is 0.03. You can see that even for 0.03 there are several accidents occurring, and if you go for abroad states and all, the limit is further increased to 0.08. So we can see that there is a voltage regulator. So this voltage regulator is for the purpose of the fact that this device can work with DC power supply and also AC power supply. AC power supply in the fact that, so this is going to be carried by policemen in their cars. So this is a AC charging, car charging unit, which we will be opening in a few minutes. So we have both DC and AC power supply. Hence, we need a voltage regulator. Okay. So now let me talk about the sensor. So the sensor that we see here, you can actually, you yourself, I would encourage you to create a breath alcohol or a breath analyzer by yourself. It's a simple sensor which you can probably get for about 300 or 500. So it's called as the MQ3 sensor or MQ303A sensor. Several sensors are available. So here you see that there is a 100 mesh network. If you closely watch, please go and check out the data sheet of this sensor, MQ3 sensor. So you can see that there is a MQ303A or MQ3 sensor, both. So this is a 100 mesh network. It's a semiconductor device. So this, what we are using is a semiconductor. So inside it has a resistor. So this resistor, what happens is, when alcohol comes in contact, it is going to change the current level. It's going to change the resistance, and as a result, current is going to flow, and the current amount is read in the LCD. So based on that, we are going to provide readings of the MQ3 sensor. This is going to be housed in a steel, in a metal housing, and you can see the terminals. One terminal for VCC, one terminal for one terminal VCC, one terminal ground, and one for signal also. Okay. So this sensor, I would like you to please check out the data sheet. I am not able to clearly show you the picture, but this has a mesh network and a metal housing for the sensor portion of it. It has two resistors, which is going to, one being the actual sensing portion and the other being the heater resistor. So both of them will be providing you the required sensing resistance, which will be again displayed in our LCD. Okay. So if you see, now we will move on to the housing portion of it, that is the outer casing. So in the outer casing, again, this is being injection molded. This is this called as the ABS plastic. There are several polystyrene, polypropylene like that. This is a ABS plastic. This is better. This is mostly, you can find the ABS plastic being used for many of the outer casing owing to its stability. So you can see that there is a cushioning portion, so that the given that is the battery doesn't overload. Even if it gets heated up, it is being absorbed. The heat produced by the battery will not affect the ABS casing due to the presence of a cushion, that is a rubber material. So this is one of the functions. So they have, so here you can see the grooves where our sensor will be placed. So from this portion, our sensor will be inserted, and here you can see that you can replace the battery. It comes like this. You can simply remove it and replace the battery, or go in for car charging option. So, and here we see that there is the AC charging port. So I'll just show you the casing first. So this is a charging port, and you have the setting for light on and off, and here the LCD display will be shown. Okay. So here if you see, this is the given port through which we will be placing our charger. So this is the usual AC car charger, which will be placed here, and this will go into your car. Okay. Now let us go in for a dissection of this charger portion. This is a very simple mechanism. So nowadays we are having the USB charger, right? So this is a bit earlier version. You just unscrew the whole mechanism and you have three parts here, one being the holder screw, and this will be the one that goes into your car. And here you see this is the fuse. So this is a safety mechanism wherein if in case the charging or some fault happens and whole lot of current from the car is being driven, the fuse mechanism will act as a safety and cut the voltage supply. So this is a fuse. Let us now open this. You can see that again this is a plastic casing. So you will be able to see the charger port and the power supply is coming in. These are actually soldered. These two portions are being soldered towards the end, and you will be able to see an indicator, light indicator. The resistor is to bring down the power according to the LED so that it doesn't burn out the LED. We have a resistor. This is the LED circuit, simple LED circuit to show as an indicator whether it is being charged or not, whether there's power supply or not. So I hope you have understood the flow. Okay, so now let us place everything back as it was. So as of now the solder has actually come out, but it should be soldered. Now we will place the casing back. Again you see that it is an easy snap fit mechanism. We will be placing back the fuse. This will go in like this, and then we will screw it back. So here we have our AC car adapter. So you just press this and insert it into your car. This portion will come to charging our breathe analyzer board. Okay. So now let us put back the breath analyzer also. So you see that the entire thing just consists of 2 or 3 components because everything has been grouped together. All the components have been grouped together. If you see here, all of these extra resistors that you are seeing on the PCB board are all of they're not similar to the ones that you use in a general laboratory session, right? They go on, there are certain package numbers which are used. So 0805, actually these are lesser than the 0805 package. So if you see, there are very small resistors and capacitors. And soldering of this is it's a very tedious task and you need great patience to do the same. A clear PCB board with wire points, and you're able to see the circuit links. Instead of the wires that go about over your breadboard, you can see there are wire links that go about. So this can be a single layer PCB or a multi-layer PCB. Here they have just gone for a dual layer wherein you can see on both the sides there are wiring and wire points. These holes are being drilled using special drilling machines, and they will be again coated with the oxide layer and copper layer. Copper layer first and then oxide, and then finally lamination and several other processes of giving out the PCB board. So now let us place it back. As you can see, it's a simple snap fit mechanism. So you have the breath analyzer, the breathing tubes, and a charger for it. So this is the sensor that I would like you to please go and check out. So we now saw the breath analyzer or the breathalyzer. There are 3 different methodologies for sensing breath alcohol content, and it follows Henry's law. So the concentration of alcohol, that is a volatile liquid, when ingested is not going to be directly digested by the body. So it will be in the blood itself. As it comes towards the lungs, the volatile liquid is going to be transferred via alveolar air via the lungs, as the result of which our breath contains alcohol. But the ratio between the blood alcohol content and breath alcohol content is not the same. It has a ratio of 2100:1. But another issue is that this 2100:1 is not going to be a constant value for everybody. It's going to vary for men, women, and the amount of alcohol that you intake also. So it is just a gold standard for a handheld device. Till now it has been working perfectly. So and other as they sense that this is going to be if they find that there is some issue with the handheld device, they go in for the next level of testing, which is going to be blood or urine testing. Those are next level of testing. So please go and see all the other methodologies also. This is a semiconductor methodology. The other one is a fuel cell tester and the IR, that is infrared intoxilizer is what they say. So please refer to the other 2 methodologies also. Thank you.